Right now, invisible signals are flying through the air all around you. Beyond the spectrum that your eyes can see, massive radio waves as wide as houses carry information between computers, GPS systems, cell phones, and more. In fact, the signal your phone broadcasts is so strong, if your eyes could see radio waves, your phone would be visible from Jupiter. At least your special eye would be able to see this if the skies wasn't flooded with interference from routers, satellites, and of course, people flying who haven't put their phones on airplane mode. You see, this setting is to protect your flight, is to protect everyone else in your flight path. Cell phones connect to networks by emitting information in the form of electromagnetic waves, specifically radio waves, which occupy this band of electromagnetic spectrum. These radio waves come in a range of wavelengths, and let's imagine your special eyes see the various wavelengths as different colors. When you make a call, your phone generates a radio wave signal, which is thrown to the nearest cell tower. If you fall from service, your phone will expand more battery power to send a higher amplitude signal in an effort to make a connection. Once connected, this signal is relayed between cell towers all the way to your call's recipient. Since your call isn't the only signal out here, cell towers managing the calls assign each phone involved their own wavelengths. This specific colors ensures you're not picking up other people's calls. It's even slightly different from the wavelengths your phone is receiving information on, so as not to interfere with that incoming signal. But there are only so many colors to choose from, and since the advent of Wi-Fi, the demand for ownership of these wavelengths has increased dramatically. With all these signals in the air, a limited number of colors to assign, avoiding interference is increasingly difficult, especially when cell towers receive too many signals at once, such as during regional emergencies when everyone's trying to use their phones. But other sources of interference are more preventable, like phones searching for signals from thousands of meters in the sky. Phones on planes are very far from cell towers, so they work overtime to send the loudest signal they can in search of service. But since planes travel so quickly, the phones might find themselves much closer to the cell towers than expected, blasting with a massive signal that drowns out those on the ground. So when you fly without using airplane mode, you're essentially acting as a military radio jammer, sending out a giant radio waves that interfere with nearby signals. Even on the ground, almost all our electronics emit rogue radio waves, slowing down our internet and making a call choppy. This leads consumers to pay for more bandwidth, pushing service providers to take over more radio spectrum and eventually send more satellites into the sky, creating a vicious cycle that could eventually blot out the stars. Though even without these satellites, this system is threatening our relationship with the cosmos. Radio telescopes used for astronomy run on specific band of wavelengths to see deep into space. However, while this range is supposedly protected, the cutoffs aren't enforced. For example, the very large array can see signals throughout the solar system from 1 to 50 gigahertz. But if looking for signals below 5 gigahertz, a search could be drowned out by a sea of phones on 5G networks. Today, nowhere on Earth is truly radio quiet. Satellites bringing signals around the globe have blanketed the planet in radio waves. But there are few places with less clouded skies where radio telescopes can look deep into space. Here, we can see the black hole at the center of the Milky Way and uncover the secrets of galaxies up to 96 billion light-years away. Well, so long as we are not blinded by phones sending signals from first class.